All right, so number one is this guy. And the answer is right there, but who cares about the answer, right? The question is, how do you get there? So
It should
sine
be
inverse
7.
square root 2 over 2.
Jack,
Yeah?
it should be chapter 7 and 12.
Oh, this is exam 2. You're right. Oh, yeah, we haven't talked about that. My bad. I guess I'm still out of it. Here it is. Yeah, that makes sense. Thank you. Alrighty. Yeah, here it is. Okay. Let's start that again, right? Let me erase that. All right, so we were here, right? And we haven't done any of these, correct? Okay. Let's start with the first one. It says write the partial fraction of this rational expression. Rational expression meaning it's just an algebraic fraction. That's all that means. Okay, so we're going to factor the bottom, do the A and B, C, etc., and then start our process. So here we go. So number one, I'm not going to write the instructions because it's right there. Okay. You write the problem down, then I'll switch over to this camera here. Okay. So we know the answer, but again, who cares? First thing we need to do is factor. What does that bottom part factor into?
X minus 6 and x plus 1.
X minus 6. Yeah, that's right. X plus 1. So these are both distinct, right? And unique. Same word, I guess. So we'll use the rule 1 or case 1. X minus 6 plus b over x plus 1. So we're going to work with this part to solve for a and b. So here we go. So I'm going to write this part over here. Okay. And we said that we're going to multiply for these questions to cancel all the fractions. You multiply by whatever is on the left-hand side, right? So this will be multiplied by x minus 6, x plus 1, and then so will each of these pieces. X minus 6 times x plus 1, and then the b, x minus 6, x plus 1. Oops, forgot the bottom part. So we know the left-hand side will cancel completely, right? So we'll be left with just the 2x minus 5 equal to x minus 6 will cancel with that x minus 6, leaving us with just the a and the x plus 1. Okay. Plus b times these x plus 1s will cancel, leaving you with the x minus 6. So this guy here, the Heaviside method would be best, the one that the homework kind of keeps using in the examples, because you have just two terms that you can cancel right away, right? So let's use the Heaviside. So you guys cool up to this point? Any questions so far? All right. So Heaviside says you just choose an x that will make this simple. In other words, cancel the a or the b. So let x equal -1. So then I got to plug it in everywhere. -1 minus 5 equals a times negative 1 plus 1, which will zero this out, plus b times negative 1 minus 6. So this guy is gone, leaving me with a negative 2 minus 5 equal to negative 1 minus 6 is negative 7 times the b, right? This right here would be negative 7b. All right, so then divide, combine like terms right here. Excuse me. That would be negative 7 equal to negative 7b. So what is b?
1.
Yeah, it's going to be 1, right? So and you divide both sides by negative 7 to get that 1. So 1 is equal to b. So b is 1. Now we just need the a. That's my first piece. So we'll use the same equation here at the top and let x be 6 this time. Okay, you didn't really have to do this heaviside if you didn't want to, because the system would have been easy too, but why not use heaviside when we can, right? Okay, so now we'll try again. This would be one piece here. So let x equal 6. So now everywhere you have an x, put a 6 into this main equation, right? So you're going to have 2 times 6 minus 5 equal to a times 6 plus 1 plus b times 6 minus 6. So this will be gone, right? Okay, so this would be 12 minus 5. This will be 6 plus 1 is 7 times a. And this is gone. So 12 minus 5 is going to be what?
7,
7, right? So what is a?
1.
Yeah, they actually both turn out to be 1. So 1. So now all you do is go back to the very beginning and put a 1 for the a and the 1 for the b, and that's what you get. Okay, so the answer will be, I'm going to put the answer right here in this little box, assuming I can write 1 over x minus 6 plus 1 over x plus 1. And that's what they have here. Let me show you. Right. If you have any questions on any of the steps along the way? Okay, let's move on
And
to.
so,
Mhm.
oh, I'm sorry.
No, you're good. What's up?
I don't understand any of this at all. Like this whole decomposition thing is really just kicking my butt.
Okay.
So I don't understand what happened to like the x squared minus 5x. Like, why do we just say, oh, we're putting it x minus 6, x plus 1?
Okay, so this first step is factoring the trinomial here. So this to here. So the first step you need to do or be able to do is to factor. So how do we factor, right? So the idea, oh, give me 1 second. Find a blank page and go back to. Oh, this will be fine. X squared minus, what was it? Minus 5x, right? Minus 6.
Yes.
So this right here, so the idea that the is reversing the multiplication, right? So let me show you how you do this. So when you multiply two binomials, you're always going to get a trinomial. So you do x times x, which gives you
You
the
might want
x
to pull
squared.
up the paper, Jack.
Oh, sorry. Thank you. So x times x will give you the x squared. So that's why we assume the first one has to be this. So that's why we know it looks something like this. This will be equal to this. The next part is, what the heck are the numbers that go here? So the way you determine that, this is called trial and error factoring for the trinomial. So you look at the constant and say, okay, what are the factors of -6? Like, all right, so you go through all of them. -2 times 3, 2 times -3, 1 times -6, -1 times 6. And then over here, you sum them up and figure out which one of these adds up to -5. That's what you're supposed to do. So -2 plus 3 is a positive. -2 minus 3 is a negative. 1 plus a -6, in other words, 1 minus 6 is -5. -1 plus 6 is 5. So then you choose which one of these is the middle one, right? So you sum up these factors. So 1 times -6 gives me -6. And when I add them together, I get the middle term, meaning that's what's going to go in here, +1 minus 6. Okay, so over here, I'll turn back to this in a second. Over here, that's what we skip that 7. So, all right, how does this factor? Factors into this. Once it is factored, you can start this process, right? Since they are distinct factors, you do A over the first one, B over the second one. But you have to know, you have to be able to factor a trinomial to get there, right?
Because we have to factor out the constant in the equation.
Yeah, so whenever you have a quadratic, it will always factor into two binomial terms. Okay, and the first one, if the first one is just an x squared, this will always just be x. And then this numbered part will be determined by this final constant right here, this guy. And then which one of these is determined by this.
Okay.
Okay. So
I think so.
yeah, so make sure you go over the factoring. So there's a, let me see. So please review factoring with trial and error and factoring with the AC method. Because this section assumes you already know how to do that, and if you don't, it's going to slow you down a little bit. So make sure you go over that, okay? And let me know if you need help during office hours or whatever, or after we finish. Does this next step make sense? Do you remember this from our first lecture, the case 1? No, that was a long time ago, but
It's, of course I remember it. It's part of my nightmares.
I guess we did start really, really rough, right? Sorry about that. Okay. Any you guys have any other questions on this first problem? We're gonna do another one similar in a second, but that's what I want to see is, remember this first setup right here is the majority of the points, right? So you factor it and you show me how it's supposed to be set up. That's like at least 60% of the points for that question. If you mess up around here, oh well, at least you knew what you were doing. You just didn't get the algebra right, right? So I'll be happy with this part at least, because that's important.
So you're anticipating getting novels back from each of us of our write-up work, right?
Yeah, I'm expecting a lot of pages, at least one page per problem. Some of them maybe not. Like for example, this guy right here. That's probably like half a page or maybe a couple of lines. This one is for sure just 2 lines or 1 line. But it depends. Like these first 3, yeah, I expect a page each because they're long. But if you run out of time, at least set it up. That's what I recommend. Okay. All right. Someone had a question for number 3, right? So we'll skip 2. Let's do 3. But the answer for number 2 is B, by the way. And then the review is not for a grade. It's just for you to practice as many times as you want.
Yeah, and when you do number 3, can you tell me which case number that one was over to? Because I kept getting this one wrong every time.
Okay. Yeah, we can do that.
So in the review, like when you click in it, it tells us that you have to do 3 attempts and then
Yeah,
the
yeah,
grade.
no worries about that.
Oh.
That's from an older class, and I think I told you guys last time, like, you can take as many times as you want. It's not for a grade. You can use those as your notes if you want. Okay. Not gonna be.
So it's not for the extra credit?
I think we discussed that, right?
I thought it was for extra credit, but I could be wrong.
I remember something about that. But if you upload all your, let me see 1 second before let me look at what I wrote.
Because I did it 3 times.
If you have your work all clean and ready and you want to upload it, yeah, I'll take it for extra credit, sure. I don't
Okay,
have
upload the
I don't have,
actual work.
yeah. If you want extra credit, I can do that.
Okay,
I don't have them. I'll have to
Okay.
open. Give me a second. I'll make that real quick.
it's just, it doesn't matter how messy it is it? Because it's real messy, but I have it.
I mean, as long as you have your steps and it's not too bad. It depends what messy is. I mean, I don't know what messy means to you. Like, is it all like in a spiral and
Well,
nobody
I
can
mean,
read
it's
it?
just a lot of,
Like,
no, you'd be able to
had-
read it. It's
had
just
one
a
guy
lot
like
of
write in
paper,
circles.
but,
That's pretty crazy.
oh no, it's not circles. There's some scribbling.
Like it was like I had to decipher what he was talking about, and like I don't know what he was saying. It was like he started one question in one corner, and then he finished like in another page. I'm like, what's going on? Let's see here.
No, it's not that bad.
Okay, then no worries. Let's see here. File. Yeah, that's fine. That'll work. Give me one moment. I'm adding the little extra credit thing for you guys. Okay, I'll make the review due by Friday night. Okay. If you want some extra points.
Thank you.
Because for me, I mean, I don't mind doing that because you're showing me that you practice and you're preparing, so it's going to be good for you anyway. Okay, let's get back to this. So this guy, x cubed minus 1, it's a special type of factoring. It's not a quadratic, right? Let me show you the formulas difference of cubes.
Oh, this one was hard.
Yeah, well, maybe we should skip it. I'm just kidding.
No.
Yeah,
I mean,
I got
found
it
the answer-
wrong all 3.
I got the answer for it, but it was like,
All right, so here's the formula we need to use, right? I don't expect you to memorize these, but this class assumes you've done this before. But in case you haven't, just remember there's a sum of cubes and a difference of cubes. So a cubed minus b cubed, we have an x cubed minus 1. So you have to rewrite the 1 as a cube. So I'm going to write this formula up top. So honestly, I don't memorize these anymore. The cubic ones, at least, I don't use them that often. A minus b times a squared plus ab plus b squared. Now, I highly recommend that all the formulas and notes that you write while you do the reviews, you take that with you to the exam, right? Okay, 13x plus 2. So the bottom, you basically rewrite it as an x cubed minus a 1 cubed. See what I mean? So then you're going to use this formula up here to rewrite it. So you're going to get, so the a and b is x and 1. So you get x minus 1 times x squared plus ab, which is 1 and x, so x, plus b squared, which is 1 squared, which is just a 1, right? So apply the difference of cubes, and then you begin the process, right? So these two are distinct, but this guy is quadratic and cannot be factored further. So you're going to have an ax plus b kind of situation, right? So let me bring up the cases. I don't remember the numbers, but I will show you just a moment. Where is it? Here it is. Okay, so if they're distinct, meaning when you factor it, they're not the same, well, we just put a and b over it, right? Remember we did all these. If they're repeated, we said, see how this one has a square in it, meaning there's two of them? You count up to that power. So 1, 2. This is distinct, so just an x, right? Who cares? The setup is up here, actually, but they already answered it here. The one we're doing right now is going to be this, distinct quadratic factor. So it's a combination of case 1 and case 3 at the same time. You see how right here, you have an x minus 1 and something that does not factor? So this is just a simple a. This guy will be bx plus c. So this is actually almost exactly the same as case 3 for the example. Okay, so that's how we're going to start. So this guy right here, 13x plus 2 over x minus 1, x squared plus x plus 1 is equal to a over the first one plus bx plus c over the second irreducible factor. Okay. So right there, if you can do that, that's at least like 60% of the points, right, for that question. I'll be very happy. But now the next part is the harder part. We need to cancel the fractions and solve for ABC. Okay. So multiply by this part down here to cancel all the fractions. So I'm going to write 13x plus 2 over x minus 1, x squared plus x plus 1 times x minus 1 times x squared plus x plus 1 is equal to a over x minus 1 times x minus 1 times x squared plus x plus 1. It's basically every single term, right? Every single term. Sadly, I am out of space. Oh well. Plus the bx plus c over x squared plus x plus 1 times x minus 1 times x squared plus x plus 1. So you take this LCD at the bottom and you multiply it on first, second, and third terms. And once you do that, the left-hand side will leave you with just this part every single time, the top part, the numerator. This term here will cancel the x minus 1, leaving you with the a and the x squared plus x plus 1. So you'll have this. Plus, this next term will lose that whole x squared stuff here, leaving you with bx plus c times x minus 1. You guys okay with this? So the first step was factoring with the difference of cubes formula. That's what we got to here. The second step was using case 3 to separate and set up the problem for partial fractions. Fourth step was getting rid of all fractions and getting ready to create the system here. Okay. You guys okay so far?
Yes.
Okay. Okay. So at this point, Heaviside will help me solve for A, but that's about it. So you might as well just expand it all and create the system. Heaviside is not good for this one. So let's expand, meaning multiply everything out.
I have a quick question though. If you're able to solve for A using Heaviside, can you just plug that in? Never mind, that won't work. I see why that won't work.
You can kind of brute force your way through it, but it'll be more work than you're gonna like. Now you could find A and plug in the A, then try your best to find one of these, but like you could find the A letting x be 1, right? And then you could find the C by letting x be 0 and plug in the A that you found. And once you found A and C, you can find B, but you can see that's going to be three or four
yeah, you don't have to
equations.
break it down. Yeah, no, I get it. Yeah, I just
Okay.
don't want to make it more confusing, but okay, cool.
No, you're right. You could, but I don't recommend it.
Thanks.
All right, so let's distribute the A. And then we're going to have to distribute these two, which is more of a FOIL kind of expansion here. So bx times x is bx squared, right? Bx times a negative 1. C times both of these guys would be cx minus c. So here we'll group everything that's the same.
There's a little glare. I can't see. There it is. I can see now.
Yeah, trying to deal with that glare too pisses me off. I wish I had a better light in this room. I think that's what it is. But anyway, I need to buy a lamp. Okay, so we'll group all the quadratics, all the x terms, and all the constants together and create the system. Okay. So quadratics, ax squared and bx squared are the only squared parts. Ax minus bx plus cx, there's 3 x terms, so plus ax minus bx plus cx. Now anything without an x is a and c. That's all of them. So now this is where we equate the coefficients to create the system, right? Instead of doing Heaviside. All right, so the idea, just to refresh your memory, as you kind of factor out the coefficient. So a plus b is the coefficient of the x squared, right? If you notice, if I pull out the x squared in front, this is some number attached to the x squared, right? So if this was 7, it'd be 7x squared, right? So you equate that to the coefficient. This coefficient will be equated to the coefficient over here. Okay, so there is no quadratic term, right? So that's what's equal to 0. Same thing with these x terms. These are the coefficients, just to remind you of what we talked about. The x equation, the coefficient of the x is 13, right? So it's equal to 13. So this coefficient is equal to that coefficient. That's how you create the system, right? Now the constants are equal
I'm sorry,
to the
how did you get
constants.
13?
So whatever's on the x is equal to this. So these pieces shouldn't be there. I'm just writing them so you can see it. Okay. So the system will be
Oh, okay.
a plus b equals 0. A minus b plus c equals 13. A minus c equals 2. So this is the system, but they come about because the coefficient of the x squared on the right-hand side is a plus b, right? If you factor the x squared. So then you look at the left-hand side and say, okay, what is the quadratic coefficient? No, there isn't any. So it's 0. Then you look at all the x's. This is the coefficient of that x. So you set it equal to the coefficient of the other side, 13. Set the constants equal to the constant, 2. That's where this came from. Okay. That makes sense?
Okay, that makes sense.
this-
Yes.
Is A minus C, wouldn't that be 0? 2 minus 2, or the
Well,
A is 2 and the C
Well,
is 2?
we have a constant over here too.
Yeah, so the A is equal to, the A and the C aren't both equal to 2, so it's not 2 minus 2.
No, I don't know what, I mean, they could be, but I don't know what A, they're not equal. A and C are not equal.
Okay,
That's
so
all.
A and C don't represent 2. That's not, the number 2 isn't represented by each of those. We're not equating those.
You can
A
you can get
minus
A
C.
if you do the Heaviside method with 1.
Yeah, you could, but the A minus C is equal to 2. So I don't know what they are, but this difference, this subtraction will
Okay.
equal to 2.
I got you. Okay, understood.
And when you say quadratic, I'm sorry, I'm still learning it's been a while, but quadratic is
The
like,
power of 2,
right?
second power. So
Okay,
the second power equal to the other side.
that's,
There's no
I just
power
want
of 2 over here, right?
okay.
First power equal to the first power. So at this point, you can use any method you want to solve it. I think I showed you the calculator was easier if you have one, or substitution depending what's going on. Now, equation 1 though implies that A and B are the same but opposite signs, right? Because they're equal to 0. So you can kind of glean that information, but that's about it. Yeah. So let's change it into a matrix. So the A column will be 1, 1, 1. The B column will be 1, 1, 1. 1B, second row, one negative B, right? Because it's negative. There's no B's here, so 0. There's no C's on the first one, so 0. 1C on the second equation, negative C on the last equation, and then the constants. 0, 13, 2. So solving this like you did in college algebra will give you the ABC. And I recommend you use a solver or a graphing calculator. But at this point, we did the new stuff. Let's go ahead and use the solver. Oh, cool. So yeah, Desmos can do it, so I'll make sure to add that too. I told you that I'm going to add the Desmos calculator, right, for your test. So you'll be allowed to use this. I'll make sure to set it up before you do it. Well, let's try it out. See if this works. Nope. We have A inverse. Yeah, here we go. REF. Okay. So we have, how many rows do we have in our example?
3,
3,
3 rows. How many columns?
4,
4.
4, right? Okay. So we have 1, 1, 0, 0, 1, negative 1, 1, 13, 1, 0, -1, 2. All right. So now, let's see here. REF, the matrix A that I made. Oh, there's the answers. Cool. That's nice of them. So they have it in fraction or decimals. Convert to fraction. So here we go. Assuming I plugged in this matrix incorrectly, 13, 2, -1, 0, 1. Oops, I did not. That's a 1, right? There we go. Now it fixed it automatically. Cool. So the row reduced echelon form of the matrix gives you all the answers you need for A, B, C, E.
That's what it stands for?
Yeah. REF means row reduced echelon form, which is just this. Which is this. Let me show you. Okay, so 1005. So ones along the main diagonal is row reduced echelon form. That's it. To see how there's no more numbers everywhere, it's just ones in the middle and your constants. So this implies that A is 5, B is -5, and C is 3. And let's see if that's right. Go check. Yeah, A was 5, right? B is -5, and C was 3. Yeah, we got it. Cool. So I'll make sure you're able to use that calculator, or if you want, I think I showed you how to do it on your graphing too. So it's up to you. But in the question, when you're taking your test, you see how it should. Oh, actually, you can't see. When you have a question open, like for example, something like this, I'll have a little link right here that you click it, and then it'll open Desmos for you, and it'll stay open for the whole test. So you can close it or leave it open, and it'll solve the matrices. It'll graph for you, and you can do some fraction stuff. Okay. Anyway, you guys have any questions on number 3 that we just did, or any part of it? Okay. So we did number 1. We did number 3. Then you feel free to write the answers. So number 1 is A, number 2 is B, 3 is D, 4. Let's see here. Would you like to do 4, or should we move on to something else? Did you have enough practice with the partial fractions?
The other ones I had problems with were the last three, the graphs. I mean, I think I figured them out, but I did have some problems in the beginning.
Yeah, can you go over the graphs, please?
Yeah, sure. We can go straight there, and then we'll come back to the beginning. So on these guys, I want you to use the graphing tool. So in this question on the exam, I'm going to put the link for your grapher, right? So let's try the page here. I'll write the question down, then I'll switch over. I don't know what number this is, but oh well. Y is equal to tangent of x minus pi over 2. Okay. All right, so I'm going to switch to the graphing calculator. This is what I expect you to do on your exam. Just go ahead and graph it, see what it looks like. So tangent x minus pi over 4. All right. So which one does it look like? If I switch to this tab, can you see it? You can still see this, right?
Yes.
Okay. So we just need to decide which one it is, right? So compared to the graph, it's going down this
Pi
direction.
over 2, Jack.
What's up?
It's pi over 2.
Oh, 2. Okay, thank you. Okay, so it's not in the center, and it's going this direction. So we can eliminate a few just by looking at that. So let's go to the review here. So for sure not this one because it's going the wrong direction. A is going through the center of the origin. So A and D are automatically wrong. Then at that point, I start to see, okay, which one is going through the correct x-intercepts, right? So then we go back. What is this point? What is this point? What is this point? So it needs to go through these guys. So let's go back and look at it. And I know we know the answer, but you're not going to know on the test. So does this go through? Well, this one's wrong already. We said this guy. Does it go through pi over 2? Yes, it does. This one does not, correct? So A is wrong because it goes to the origin. B is wrong because it does not go through pi over 2. C is wrong because it's going the wrong direction. It's actually reflected. D has to be the answer. Okay. So on these graphing modes, all I want you to do is just graph it on here. So for this next one, secant, we do the same deal. Secant x minus pi over 2. All right, well, which one is it? Let's go compare them again. I'm not going to force you to graph these by hand. That's a few questions I'm not going to expect you to do by hand. All right. So A, why is this wrong? Well, it's going through the center, right? This one doesn't have anything in the middle. This one does. So A is wrong. B, see, why is B wrong? We have values at pi over 2 and negative pi over 2. So let's compare those. Pi over 2 is right here. So I don't have any points there. You see that? This one does. So do I have it down here or is it up there? Let's see. Pi over 2 is up top. But the other one had it at the bottom. You see that? That's why it's wrong. So this is just doesn't make any sense. It's not even a secant graph. But you see what you have to do, right? Just eliminate the ones that are wrong, obviously. This is wrong. Does that make sense?
So how do we do that on these calculators? Because I don't see secant on here.
Secant is defined as what? 1 over cosine, right? So you would plug in for the graph 1 over cosine, and that's it. So let me show you. Can you see this?
Yes.
Okay. So you do, so secant, you have to remember, what does secant mean? Well, it means 1 divided by cosine. And then you graph it. Although that was x minus pi over 2. I forgot about that.
I missed it. I was like trying to write notes.
Oh, it's okay. So
yeah,
you press y equals, and you do 1 over cosine because that's what secant means.
Oh, yeah.
So then you put x minus pi over 2 in here, and then just hit graph.
Oh, okay.
And then at that point, you can graph it. You might see it doesn't have the tick marks. So you'll have to try to trace it. So it'll be a little bit harder, but this can still eliminate it because on the other one you can kind of click right away, right? But here you'd have to hit trace and try to figure out, okay, what is that value? You see what I mean?
Right.
So you have to estimate using the decimals, not the exact numbers. So what pi over 2 would be about 1.7, right? So you have to do it that way instead.
Okay.
But you can eliminate right away 2 of them, right? Because you see how our graph doesn't have anything in the middle. So A is wrong just by looking at the picture. This is nowhere near close. So A and D are automatically wrong. So you just gotta have to determine, is it B or C? And you can kind of figure out by the shapes, right? See how this one is closer to our picture?
Mm.
So it should be clear most of the time, which the answer is once you graph it. If your graph comes out weird though, you'll have to hit zoom trig. So hit the zoom button and go down to where it says trig, number 7. So it can give you a better picture. Sometimes it's set up for like parabolas or other stuff, which is not trig function. So you'll have to zoom in to this type of graph. Okay. But yeah, that'll be the same deal for the last 3. It'll be the same thing. Just graph them, see what they look like. Okay. So I'm going to go easy on you on the graphing portion because we didn't go in depth. And I want you to use your graphing utilities instead. I don't want you to do it by hand. But you can if you want.
Man, that's like a third of the test.
What's that?
I'm not complaining. I'm not.
Jack, I can't figure out the number 15.
Mine aren't numbered. Which?
Minus 2 pi.
What is it? Sorry.
Sine mine like sine,
This
and then in brackets, no. Yeah, that one.
Okay. Just find the exact value. Do not use a calculator. Okay. Well, sine of negative 2 pi, that lands on 0, right? Let's
Yeah.
look at our circles. Oh, 1 second. Okay. Sorry. Brother was bothering me. All right. So, where is my circle here? Let me go find it. And let me write this question down. Well, maybe we don't need to. Okay, so here's 0, the starting point for whenever we do angles, right? Pi is right there. 2 pi is right here. So negative 2 pi means I'm going to go this way and then over here. So you see how it's the same thing.
Yeah.
We end up in the same spot. So the question becomes, what is sine of 0? Well, the y value is 0. So going back to that question, the first piece, where the hell did I put it? This first piece is 0 right here. So we're really just going to need to worry about this guy.
Yeah.
What is cosine 5 pi over 2? Well, okay. Where the heck is that? Let's look at our circle again. So 1 pi over 2, 3 pi over 2, 5 pi over 2. So it's not technically on here because it's more than 2 pi. So remember how we said that if you go around the circle, or if it's too big, what you do, so we take the 5 pi over 2 and subtract 2 pi, right? Do you remember that?
Yes.
And then we
Which is
figure out,
4 pi over 2.
now where am I? Here we go. So find the denominator. So that'll be 5 pi over 2 minus, multiply by 2 over 2 to get the denominator, 4 pi over 2. So 5 minus 4. This
Pi over
pi, yeah. So this, which is pretty much we could kind of see, right?
Yeah.
But if you didn't see it, that's how you would do it.
And
So
then I
then
do sine of pi over 2.
Yeah, so cosine of pi over 2 is 0. So you have 0 plus 0 as your answer, which is, of course, 0.
Okay, thank you.
Right? Yeah, that's what they got. Does that make sense to everybody? And you're just using the unit circle to help us out. There's not much work that I'm going to require on this because these are kind of simple, but you could show that the 5 pi over 2 is the same as pi over 2. That'd be the only thing you can really do as far as work. But I wouldn't be very picky on this one because there's not much to do. Let's go back to the top here. You guys comfortable with converting from degrees to radians or radians to degrees?
Sorry, real quick question. Is the unit circle going to be available on the exam?
You're welcome to use it. I'm trying to think. I don't know if I can try to create a link for you. But if you can print it out, that'd be great. That'd be fine. I mean, I don't know if you will be able to open another tab for the PDF, but you are allowed to use it technically. And I would like you to use it. But good point. I'll try to figure out a way to create a link for you in the meantime. But if you can print it, that'd be great. Any questions on this one, though?
Oh, no, I was
That one
good
okay?
on that one. I was gonna ask if you could do
Which one?
Number 10.
10. Which one's
Use
10?
the it's the one that has 10, 0 equals 3. Find secant theta. I'm sorry, theta.
I have one right now.
This one?
Yeah.
Okay.
Yes, there it
This
is.
is number 10, you said?
Yes.
Okay. Okay, let's do it. All right, tangent of theta is equal to 3. Find sine theta. So basically, they give you information to create the triangle, and then you need to find the sine. So, draw your right triangle. Shit, I'm so zoomed. That's why everything was weird. Okay. It's a really ugly triangle, but oh well. You can tell I was really bad at art school.
Oh yeah.
Yeah, I know. All right.
That's why you went to math, right?
Basically, yeah.
Same.
Yeah. Music was all right though, but not art, and I can't do anything. All right, so how do we define tangent? Do you remember?
Opposite over adjacent.
Opposite over adjacent. Yeah, that's right. So technically, there's a invisible one down there. So here's theta. So opposite's right here. Adjacent's right there. So now we just need the hypotenuse. So we know that Pythagorean theorem says that the legs squared added together is equal to the square of the hypotenuse, right? So 1 squared plus 3 squared, what is that?
10.
10, right? Yeah, 10. So what is C?
Square root of 10.
Yeah, C equals square root 10. All right. So we have the hypotenuse now. So how is sine defined?
Opposite over hypotenuse.
This is opposite over hypotenuse, which is going to be 3 over root 10. If we were to rationalize this, you would multiply the top and bottom by root 10. Because the test will probably make you do that. So you'll have 3 times root 10 over square root of 10 times square root of 10 is square root of 100, which is 10. The square roots cancel out. So this will be sine. And that's what they have here. Yeah, there it is. So use this to make the triangle, and then write down what sine is based on the definition of sine. That's all you got to do. Is there any steps that don't make sense?
How did we get the 1 for the side? I forgot.
Oh, so all whole numbers, actually any number, can be written over 1. So 3 is the same as 3 over 1, which allows me to create that adjacent side.
Okay, that makes sense.
Because, right, 3 divided by 1 is still 3, right? So you can do that anytime you want.
Yeah, and I guess that's what was throwing me off because number 9, I worked it out the same way, but it gave us,
I'll give you a fraction.
yes, yeah, it gave us the 2 and the 5. So yeah, I couldn't figure out how to get this one. I mean, I knew the answer, but I mean,
Gotcha.
I was, yeah, okay,
Cool.
thanks.
Well, it makes sense now, right?
Yes.
Okay.
I have a question.
Yeah, which one? what's
Number 9.
Number 9.
And I had more trouble with like identifying the sides. Like I got the answer right, but it took me like 2 hours and to find out because I had the wrong sides. How do you I don't know if I forgot, but how do you like what's the way of figuring out like A, B, and C?
C size. Okay, let's see. Let's go through this. It's this one right here, right? This guy.
Yeah, that's correct.
2 sides of the right triangle, ABC. C is the right angle. Are given. Find the indicated trigonometric function. Okay. Find secant B when A and B are 2 and 5. I see. So basically, the ABC is giving you a hint that this is a right triangle, meaning
Okay.
you are allowed to use Pythagorean theorem. These right here are the sides, because C is reserved for the hypotenuse, right? Little
Correct.
c. So we're going to square and add these up, do the same thing we just did to find C. Once we have all 3 sides, you can start finding a definition of secant. So let's go ahead and do it. So let me draw this out.
I think I just got confused because I just have the habit of like drawing the triangle, and I don't think I need to. And I guess I just confuse myself when I do that.
No, I mean, the triangle helps, I think. Let's see here. A was 2, right? B was 5. So we have a triangle. That's a right angle triangle.
Pull up your paper, please.
Oh, yes. Thank you.
Thank you.
Okay, so this is A and B. Does it matter which one? No. You can swap these if you want. What matters is don't put 2 or 5 on the hypotenuse because I don't know what that is. We have to find it.
Okay.
So same deal, right? C squared is equal to 2 squared plus 5 squared. So C is equal to the square root of 4 plus 25, which is 29, right? So square root of 29 is that guy. So now what is secant?
Hypotenuse over adjacent.
Yeah, so secant of B. All right, I'm going to say that this is B.
Four plus 25 over what?
Sorry, I was thinking. One more time.
Square
Oh.
root.
Yeah, square root of 4 plus 25. So let me write that a little prettier for you. Sorry.
So Professor, I'm looking at my notes that I did, if I didn't put that square root over the 4 plus 25 with that, would you have counted off, or am I supposed to write it as square root?
No,
4
you can
plus
just you could
25?
just say square root of 29 if you want.
Okay, okay.
Oh,
2 squared plus 5 squared. That's going to be, so if I show my steps, it'll be 4 plus 25. So C squared equals 29, which means I have to square root both sides. Okay, that's where the hypotenuse comes from. Okay, So this said A was 2, so this will be A, capital A, and this will be capital B. C is the right angle. Usually it's best to, if you have a little a, you do the opposite to be capital A. So opposite to this is capital A, opposite to little b is big B. See what I mean?
Okay.
Just in case it matters. That's usually what we're going to do in the next chapter. I think it is chapter 9. So later. But anyway, so secant B, we said is hypotenuse over what again?
Adjacent.
Okay, so that would be square root 29 over adjacent. Right? So adjacent to B, so 2. This will be my answer.
I can't see your paper at all.
Is it getting too bright? Give me a second. It's like right on the glare. That's why. Okay. Give me a moment.
That's great.
Is that okay? Or
Yeah, that was good.
yeah, I'm struggling with the lighting in here. And this crappy pen. I only have one pen left, and it's light blue. So if now I can switch to pencil. If this is not legible.
I think the pen is good.
Yeah, I can see it.
Okay, so let's go through it one more time, right? So they gave us A and B. That gave me the size of the triangle. You use the Pythagorean theorem, which I did here, to find the hypotenuse. Once you have the triangle made, you can find any trig function, sine, cosine, secant, tangent, whatever. They wanted secant. So you need to know what is the definition of secant. I wrote it here, and then here's hypotenuse and adjacent. B is the one I chose to be there. Okay. Any questions on that one? Okay. You guys have any other questions on the review?
Yes, so there's one that talks about that one side is so high,
Mm-hmm.
and then they want to hang something at 10 feet from that height.
Oh, yeah, the guy wire, right?
Yeah, yes.
This guy here. Yeah, okay. Yeah, we did something similar, but let's go ahead and do it. I remember this one from the examples. We had to figure out exactly what they mean by the 10 feet, and that throws things off. Let me see here. Give me a second. Is that better or too dark? What do you think? I took the glare off.
It looks good.
All right, we'll try it. If it is better, then I'm going to buy a lamp. Okay. So radio tower, 230 feet tall. So let me write all this information down. How long should a guy wire be if it is attached to 10 feet from the top? Okay. So you picture a tower, and then there's like a little attachment on top that's 10 feet above the tower. So the wire is attached to the 240-foot mark. Um, and then the angle from the top, hold on, 10 feet from the top, and is to make an angle of 33 degrees with the ground. So when you attach the rope or wire to the ground, there'll be a 33-degree angle from the ground to the wire. Okay, so I need to draw all this. Okay. So I don't know what number this is.
12.
Number
12?
12, buddy.
Okay. We don't know the base, correct?
Correct.
Okay. So let's say from here to here is 230 feet. This angle from the bottom of the ground to the top is going to be,
33 degrees.
yeah, 33 degrees. Thank you. Okay, so this little extra tip is where the wire is attached above the tower. So this is 10 feet. Hold on a second. Trying to get light on here. Okay. All right. So guy wire is 10 feet from the top. What do they want to know? How long should the wire be? So they want to know the length from here to here, right? So basically they want to know the hypotenuse. But we're missing the one side and the hypotenuse. So which trig function should we use to help us out?
Sine.
Yeah, I think sine would be good. So we're going to use sine of 33 degrees. And use the definition that that is equal to the opposite side over the hypotenuse. Opposite side is going to be what?
220.
240.
220.
220. Let me see. Oh, this is from the top, right? Not above it. Ah, I see. Yeah, they tricked me a little bit. So the wire is actually attached. Yeah, at the 220 mark, right? That's what you're saying.
Yes, sir.
Thank you. I misread that. Let's redraw this pretty picture here. This beautiful art project. Okay, so we have this thing. So we'll attach it right here. So from here to here is 220. This thing up here is the extra 10 feet that we don't really need. So they kind of make it more complicated than it needs to be. So sine 33 will be equal to 220 over the hypotenuse. So you need to solve using algebra the hypotenuse. Okay, so multiply both sides by hypotenuse. Or if you prefer, you could do the cross multiplication thing, but I don't like mentioning that. All right. So then these will cancel, leaving you with hypotenuse times sine of 33 equal to 220. So divide by sine and you're done. So hypotenuse will be equal to 220 over sine 33. What is 220 over sine 33?
403.94.
How much?
403.9.
403?
0.9.
Gotcha. So is it better without the y? I can't tell from my end. Was it
Senor, have
worse?
you cleaned the lens?
Maybe. Let me try that. It's a good idea. Give me a sec. Is it better without light or with light? I can't tell. Just with light.
It's a lot more better right there.
With light.
Nice. So we'll leave the light on then. It's just eventually, sometimes when we have that glare, you just gotta work around it, I guess. But anyway, the idea, does it make sense, right? We set up the problem, draw the picture, it always helps. Then use one of the trig functions that you gotta choose. So most of the time it's tangent or sine. That you usually do it for you. Since I don't have the adjacent side, I don't want to use cosine, right? Since I have opposite, I want to use sine. If I had both of these sides, then I'd probably use tangent or something, or Pythagorean theorem or something. Okay. But you have to make sure you read the question carefully, because originally I thought they meant 230 plus 10, but they meant 220 plus 10. So if you were to use the 230, you would get the wrong answer. But if you showed all this work and setup, I'd still give you most of the points, even if you put 230 or whatever, 240, because it shows you understand it. But anyway, is there any questions on that problem?
Number 13, if we can go over that one.
13, which one is that?
The one above that one.
This one?
Uh-huh.
Okay. Find the exact value of this guy in quadrant 2. Okay. Oh, find cosine. I get it now. Okay, let's do it. Okay, so tangent theta is equal to negative 2/5. All right, find cosine. So we need the hypotenuse, right? Because we know, well, first of all, we need to understand a couple of things. They said theta is in quadrant 2, right? So what does that mean? That means sine is positive and cosine is negative. So tangent is equal to opposite over adjacent. So if I put theta here, opposite would be positive, adjacent would be negative, because adjacent is related to the cosine. So quadrant 2 is telling me that information right here about quadrant 2 is telling me to put the negative on the 5. So now we need to just solve the hypotenuse. So same deal. C squared is equal to negative 5 squared plus 2 squared. So C squared is equal to 25 plus 4. So C squared is equal to 29. C is square root 29. Okay, so what is cosine? Defined as
Adjacent over hypotenuse.
yeah, so adjacent over hypotenuse. So that will be negative 5 over square root 29. Came out all weird. There we go. So rationalize the denominator and we're done. So multiply top and bottom by root 29. And you'll have negative 5 root 29 over 29. And that's what they have here. D. Does that make sense, or is there any steps that don't make sense?
I have a question with the theta is in quadrant 2. Could you repeat? Like, could you give more info on that?
Yeah, let me show you a picture.
Because I got the answer right, but that's only because I guessed negative 5.
So they said quadrant 2, right? So that means we're over here. But notice how all the x's are negative, right?
Right.
And all the y's are positive. But we know that tangent is technically y divided by x, right? So if tangent is negative and we're in quadrant 2, that's telling you that x has to be negative and y has to be positive. So when I made the triangle, the x or the cosine part needs to be negative. You would not put it on the y, because if you did, the question would come out wrong because it'd become positive here at the end.
Ah, okay. Makes sense.
So you need that information because they don't tell you, right? Like, is it negative on top or is it on the bottom? Is it on the 2 or the 5? I don't know.
Huh. Okay.
Jack, so for the exam, you said we can use one sheet of paper with just like formulas and stuff.
Yeah, you can use a page front and back with your formulas and definitions. If you want a separate page for your unit circle, that's fine.
Okay, and then like just have extra paper for our work and then write out as soon as we're done.
Yeah.
Scan it into you.
Yeah, I would suggest as you do each problem, show your steps and then move on. Because that's what I'm going to be grading. I don't really care what answer you choose. Most of the points would be from your work. So like if you chose the wrong one, I can still give you all the credit if your work's good. Okay.
Okay.
But I also don't want to see a right answer and no work. I probably won't give you anything unless it's the graphing questions, because there's nothing to do. The last three, I don't expect any work. I don't know how many graphing questions you'll have, but yeah, I'm just saying any type of graphing, um, I don't require work.
And like, you know, with the other, like for instance, with partial fraction, there were like other cases, but you only hit us with like 4 on this practice test. Should we expect that there will be like different cases other than that what's on here? So like know how to do all of them or
Um,
just focus on these?
I mean, you should know how to do all of them. I don't know if I'll have anything different because this one does um, repeated and distinct at the same time. This does the non-reducible. So this is like case 1, 2, and 3 all in one right here.
Okay.
This is case 1. This is case 3, or well, this is case 4. So pretty much all the cases are already here in the background, technically. The one that didn't come up was the long division.
Yeah.
Um, I don't know if that's on there, but you know what? I'll check real quick. Curious now.
You can show us a glance of that screen if you like.
Just because I like you guys, I'll tell you if there's one of those, right? Let me see here. There is not a long division type.
Okay.
Okay.
Thank you.
You guys have any other questions on the exam review?
Yes, number 8.
8. Let's see. 1, 2.
The
This
linear.
one's okay. The traveling in a circle thing.
Yeah.
I'm not sure. I'm just going by the work I have, and I put like little asterisks on the ones I didn't understand. Oh yes, that one.
So find the linear speed. Okay. So that would be a formula that we need. Let me write down everything here. The object is traveling with a radius of 10 centimeters. So what number was this again? Number 9? Or I forget.
8.
8? Okay.
Number 8.
Okay, number 8. So radius R is going to be 10. So I'm going to go ahead and write all this down. Seconds is 20. So we'll say time is 20 seconds. Central angle theta, we'll say theta is equal to 1/3 radian. What is the linear speed? Okay, so now I need to find the linear speed formula because I don't remember. I think it's,
V is equal to S over T.
yeah, V, right?
Yeah.
S over T. S is going to be what though?
R times theta.
R theta. And theta, all theta needs to be in radians, which it is. Okay, yeah, we got everything we need then. So S will be 10 centimeters times.
Jack, you may want to go to your paper.
Oh, yeah, thanks. Let's stop sharing here. All right, so 10 centimeters times theta 1/3. So that would give me 10 thirds centimeters. So now velocity will be, it's got blurry on me all of a sudden. There it goes. Velocity will be S divided by time. So 10 centimeters over 3 divided by, I could just write the division symbol, time, right?
Yes.
Okay, so that would be the same as saying 10 centimeters over 3 times 1 over 20 seconds. Okay, so that will give us, let's see here, 1/6. Yeah, centimeters per second. But yeah, it's basically you just need your formulas. Once you write everything down and use your formulas, it shouldn't be too bad. But does this make sense or no?
So the answer is 1/6.
Centimeters per second. So they write it this way. 1/6 centimeters per second. That's the
Oh,
speed, the linear speed. All right, guys, I'm just about out of time. You have any last minute questions? On anything we went over or no?
Man, we went over the whole review.
Yeah, I guess we hit pretty much most of them, right?
Yeah.
Thank you for going over everything.
No, yeah, no worries.
So we all get extra credit then, right?
Yeah.
If you show your nice detailed work on all the questions, sure.
It's gonna look a lot like yours. So don't worry about that. No, I actually do have a question though. As far as the speed, when did we go over that? Like what lesson was that? 7?
We briefly did it on like the second lecture, I think. Like after we finished the partial fractions, we talked about linear speed and arc length. Remember the distance around the circle? We only did like 1 or 2 examples. We didn't hit it too hard.
I think it was 7-2.
Yeah, I think so. 7-1 or 7-2.
Ooh, thanks.
Mhm. All right, guys, we can do some more on Thursday, most likely. So keep practicing and bring some more questions.
Jack, is the test open or not yet?
Yeah, it's open.
Okay.
You can take it whenever you want. It closes Sunday night, I believe.
At midnight.
Yeah. But
Okay.
make sure you take it 2 hours before, because if you start at 11, it'll close at 12.
Okay, no problem. And if you don't mind unlocking that chapter questions for our homework.
Yeah, I will.
So
Thank
we're going to start 8.1 on Thursday or next week?
I haven't decided. I might do more review or might do a little bit of 8.1. We'll see.
Okay. Okay.
All right, guys. I'll see you Thursday.
you. Have a good night.
Thank you.
See you later.
Thank you.
Thank you.